Well, 1, 2, guess biggity boo. Let's get started. Logarithms. Logarithm is the inverse to the exponential function. Now, at some point, I hope, in high school, most likely around grade 11, maybe earlier, maybe later, you're going to run into the logarithm. And you're going to be studying functions at some point, and what I hope will happen is that you're going to talk about inverses. Now, I am going to make the assumption that you have some background of understanding what the inverse is. Now, if you've forgotten it, I'll put up a link up above because I introduced it in grade 11 for students who want to learn about that. And I'm going to just take now and talk about the inverse basically of the exponential function. And I'm going to take just the parent exponential function, so the basic one. Now, if you recall, if you have, okay, so let's say the function, which is exponential, okay, so the simplest one, which I'm going to kind of designate it like this, we're going to make assumption that the base is going to be, let's say, greater than 0 and that it does not equal to 1. And that is something you should know after studying exponentials. Now, here, our b to the x, okay, I'm going to put inside here, so that's going to be my function inside of there. And if you recall, for inverses, what we want to be able to do is we want to be able to provide an input into a function. So in this case, the input becomes the exponent. We get an output from that function, and now we want to find the inverse function. So we want to find the inverse function, which we typically designate like this, so that from our output, we can return back to the input. That's the inverse function. So it's input coming in, x, goes through our function, which is an exponential. Something happens, there's an inverse, which we're going to call a logarithm, and we're going to get our input back. Now, let's take a look at an example, and I'm going to kind of specifically, let's set our b, okay, just for convenience, for instance, equal to 2. It can be anything, okay, which is greater than 0, okay, just as long as it doesn't equal to 1, because if our base is equal to 1, it kind of defeats the purpose. So here, what I'm going to do is I'm going to do a table of values to remind you of this whole inverse concept. And then I'm going to use graphing to try to show you. I'm going to take the points, I'm going to graph kind of the points of the inverse, okay? So the inverse has to be reflective in the y is equal to x, okay, line. So it's reflected there. And then I'm going to tell you, okay, what do we call this inverse for these exponentials? And I kind of will tell you why it has this funny name. Okay, so I'm going to do the table of values in fast forward fashion. All right, so welcome back. So here is our input that we have, and then here is our output. Okay, so that's our function is just b to the x. So all I have done is, so for -3 input, so that's the exponent, you know, we get our answer, which is going to be 1 over 8. And then -2, you know, we get 1 over 4, and so on. 1 over 2, 1, 2, 4, 8. Now, we know that we chose our base is equal to 2. So we kind of know how this looks like, especially as you have studied these exponentials. So what it's going to look like, it's going to kind of look like this, right? And it's going to blow up on us like that. Where this right here, okay, so these would be the points that we would have. So one would be here, you know, it would be here, 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 and I think you get the gist, okay? So how this would look like. Now, our interest is that we want to be able to find the inverse, which is basically a reflection in the y is equal to x line. Now, I don't know if I can do this in a really good way, but I'll give it a shot. Okay, let's say this was our y is equal to x. Y is equal to x line, and we want to find the reflection of this. And, you know, how would this look like? Well, we could kind of guess a reflection of this. And based on these points, remember what we want is, if we have our output now, so if our output right here, so that's our y, is right here, that becomes our new input into the inverse. And then our inverse function is supposed to spit out our original input that we put in, so our x back. So really what we are doing is, so again, remember we have xy. In order to be able to find our inverse, all we do is we swap the x and the y, because now our input is our y, right? So that's what happens here. And then we get our output x. So if I would do the table of values, then the table of values would just swap. So it would just swap on the other side. And that's what would happen. So my new x becomes 1 over 8, which means my output becomes -3, okay, and so on. So I'm going to do that as well, do that in fast forward fashion, just to have a reflection back. Okay, so there we have it. So our basically goal is to be able to find the input back. Now for exponentials, the input became actually the exponent. So what we're looking for is, if someone gives us a value, we want to know what exponent will that be if we know that the base, in this case the base was 2, but it could have been any base. So that's our ultimate goal. And if we would be plotting these, because we would be having an inverse. So if you look at this now, because I have some intuition and I've done this in the past, you know, you may not be able to see it right off the bat. But if you swap these, okay, and you try to reflect it along the y is equal to x, what you're going to find is, you're going to find basically something like this. Where these points, okay, that we had, because they are just reflected along here, so this would have been 1 point. Okay, this is the other point. You know, this is the other point. You know, this is the other point, and so on. Okay, so you would have gotten these points, which are basically a reflection. That would have been our inverse to our exponential function. Now, I just want to show you, let's plot it on Desmos as well so that you can see it. So I'm going to plot these in. I'm going to plot all the points, both that the ones that are on the exponential, so 2 to the x, and then I'm going to plot the other ones, and then I'm going to show you, okay, what we actually call this inverse. This inverse has a special name. Well, the video was called Logarithm, so that is the name. Now, it's a funny name, but it's so important in sciences, as if you carry on, okay, in mathematics and sciences, engineering, and others, that we actually gave this special name. Inverses do not generally have a special name. They'll just are inverses of functions. But for exponentials, okay, they play such a big role for us in so many different ways that we utilized and we gave it a special name. And we called it logarithm, or log for short. All right? So let me, in fast forward fashion, just plot these points for you. All right, so here are the points. Now I've added -4 actually, which is 1 over 16. And then I've also added, 3 and then 4. Okay, so we have them and we can see this blowing up. Now, this is supposed to be y is equal to 2 to the x, right? Which you notice that's exactly what it is, right? It basically blows through right through those points, okay, as we're going along. Now, the inverse of this, okay, is supposed to be reflected in this line. So now let's see it. Now I'm going to, again, in fast forward fashion, just plot the points for us, just so that we can see the reflection there. All right, so there you have it. So notice the nice reflection of those points that we have that basically is creating an inverse. Now, I'm going to go back here, and this inverse that we have, which basically all it does is it takes in as an input a number, and notice that the domain on this, because that it is an inverse of our original, and our original, so b to the x, our domain on that was, from negative infinity to positive infinity. But the range was everything above 0. Which now means that because we swapped the x and the y, now the domain on this inverse, okay, notice is going to change. And the domain is going to be, that is going to have a domain which is all of our numbers have to be greater than 0. So you can't have a negative number in this inverse, okay, as an input coming in. So it's going to be kind of all positives going forward. And now as we carry this through, so this inverse that we have, we've actually dedicated it and we called it a special name. We called it logarithm. And we write this function as basically log. We put a subscript on whatever base that we are using, 2, and then whatever the input is. Okay, so this is our function. Now, what we have, so if you think about this and you go back, we had y is equal to b to the x. And basically, this can be written in exactly the same way as saying, now our input is this y, okay, and our output is this x. So what we're saying is that our x is equal to, and we write log, which is the inverse of our base, b, to whatever that original output was. Now, of course, I swapped it in here because when we plot it, we typically have x as our independent variable in this case, okay, and it is on the horizontal. But this is what it actually means. So we have this and this. And for our example, so what we had 2 to the x, which means, okay, so that the inverse is log 2, okay, of whatever input that we have in here. So that input that we go in there. So it has a very special name. So that inverse, instead of writing f, to the -1 as the inverse, we actually write log. We say whatever base it is, and then we spit out, okay, as our answer, the actual exponents. And it is so powerful, and it is used in math that we have, it even pops out on the calculator as its own kind of, it has a special, so notice that there's a log, okay, notice that there's a log and it has a base, so it's asking you for the base for us. Now this app actually has log of the base, okay, right there. It has log of 2 where the base is right here, okay, so this is what we see, okay, so it already gives you the base of 2, and then it has a log. Now, when it's just written as a log, it assumes that the base is 10. And that is most commonly used because for decimals, as you may remember, it's always powers of 10. So that one dominates. So on a regular calculator, if you picked it up, that's what you would have mostly seen. You probably would just see the word log, and that means the base that they are assuming is 10. Now, if I graph this, so if I go back here to decimals, and now I want to graph this as an inverse, you don't have to do anything special. like we did in the past for inverses, trying to find exactly what the inverse is, because we are now telling you that the inverse, so notice if I go here to functions, I'm going to go to miscellaneous, there is an actual log. Now there's two, there's log and then log A. Well, they call it log A because that's the base. Now I'm going to say that, well, we used base 2 for that. So I'll put it in here, okay? And if I plot this, okay, notice it goes through my points. So whatever the base would have been, you have to always, okay, put that base within your log so that you have it. That is actually the inverse. That's what logs do. So log is the inverse. It finds your exponent for the exponential functions, which is a pretty neat thing to be able to have. Now, where do these logs come from? And I'll put maybe in the show notes a link. Okay, there's a neat article. Okay, so credit to them. They wrote a neat article if you want to go through it. So logarithm, the word logarithm, because it's a funny word that we have in here, it actually comes and it was introduced by John Napier. And I think it was around maybe the 17th century or something. So it's quite a while back. I mean, it's not too far back, but it's, you know, it's a few hundred years back. And the word logarithm has come from Greek. And it comes from two words, logos, so that's where you see that log, okay, so logos means ratio, which should make sense to you in math. Oh, that's a, you know, ratio is some kind of a ratio between, okay, and arithmos means number. So it's a ratio number, and for short, we always just use log to some particular base that we want. So some base b. That's the introduction to the logarithm function for you. So again, remember that logarithm is the inverse to the exponential. That's what you have. And you're going to learn quite a lot about it if you continue in grade 11 onwards. All right, thanks for watching. See you in a future video. Bye, everybody.